In this video, I'm going to talk about how to calculate the normal distributions in your quartile range and how to calculate different percentiles of the normal distribution. Okay, I'm going to be talking about example 6.11 in the Introductory Statistics OpenStax book, which is available for free to download via this link. My calculator is going to be Excel, but you could also use a graphing calculator, and if you go to this link, they do provide detailed instructions about how to use a graphing calculator. Alright, so let's get started by reading through the question. In the United States, the ages 13 to 55 plus of smartphone users approximately follows a normal distribution, with a mean and standard deviation of 36.9 years and 13.9 years. Using this information, answer the following questions. Okay, so they basically have told us that if X is the age of smartphone user, then that follows a normal distribution with mean 36.9 and standard deviation 13.9. Remember, this notation means distributed as normal. The n is normal. The first parameter is always mu or mean. The second parameter is always standard deviation or sigma. Okay, so question A asks us to calculate the interquartile range. The first thing you need to know is what is IQR? What is interquartile range? Okay, IQR is the third quartile minus the first quartile. Okay, so what is the third quartile? What does that mean? Well, if I have my normal distribution, it's centered on its mean, 36.9. The third quartile is where 75% of possible x values are less than whatever the third quartile is. Okay, and then the first quartile is where only 25% of possible x values is less than the first quartile. All right, so I can use Excel to find both the first and third quartile, and then I just need to subtract them to figure out what the interquartile range is. Okay, so let's go ahead and go to Excel. Okay, so click on one of the cells, type equals norm.inv, and then open parentheses, probability. So I'll start with the third quartile. So that would be, the probability is 0.75 to the left of whatever the third quartile is. The mean of this distribution is 36.9. The standard deviation is 13.9. Close parentheses and press enter. 46.275. Okay, so I'll write 46.3. I'll round to one decimal place. All right, so the third quartile is 46.3. All right, now to find the first quartile, I can actually just double click on this formula, and the only thing that I need to change is that 0.75, change it to 0.25. All right, and there's my third quartile, 27.5. 27.5. 27.5. All right, then to find the interquartile range, all I need to do is subtract these two numbers. So 46.3 minus 27.5. All right, so when you do that subtraction, you can just plug that into your regular calculator, and you'll get 18.8. So the interquartile range is 18.8. All right, next, moving on to part B, 40% of the ages that range from 13 to 55 are at least what age? At least what age? All right, let me start by drawing my distribution again. Here in the center, I have 36.9. Okay, so 40% of the ages, so 40% of these x values are at least what age? All right, let's start thinking about what does at least mean. So for example, if someone were 60 and we said 40% are at least 60, then that would mean that they are 60 or more, right? So at least means that number or more. So 40% of these x values are whatever this number is at least this age or more, right? So if I were to have a line here and some number here, I don't know what it is, I'm just going to use K, right? It's some age, I don't know. 40% is at least this age, so 40% is whatever K is or more. So I have this 0.4 is to the right of whatever K is. All right, notice that I drew K to the right of the mean, right? And I didn't draw K down here. That was actually a conscious choice because I know that this cannot possibly be 40%. This is more than 40%, right? How do I know that? Well, remember that the mean is the halfway point. So this in red is 50%. Right? So I know it's less than 50% because 40% is less than 50%. So I know that whatever K is, it must be some number more than whatever the mean is, more than the mean. Okay? All right, so let's see. Before I go over to Excel, I know that Excel, the inverse function, works really great when I have a probability that is less than whatever the K value I'm trying to find. Right? So I can't plug in 0.4 as the probability in Excel. It won't work. I need to know what is this less than probability back here. Well, the total probability under that curve is 1. So back in this area in red, this has got to be 0.60. Why? Because 1 minus 0.40 is 0.60. Okay? All right, so now let's go into Excel and I can figure this out. Figure out what K is. Let me delete what I have there. Okay. Type in enter norm.inv. All right, and remember probability here, it's asking for the probability, it's the probability to the left. So that's 0.6. The mean is 36.9. Standard deviation is 13.9. Close parentheses and press enter. 40.42, okay, or if I would round that to one decimal place, 40.4. So this K is 40.4, all right, which makes sense because that's a number more than this mean. So I told you it had to be to the right. Indeed, we found a number that is bigger than the mean. Good, 40.4. So 40% of ages are at least 40.4 years old.